2.2. You are correct. So in section 2.2, we're going to be talking about solving absolute value equations. So to kind of preface this, let's solve a couple of very, very simple, basic absolute value equations to just kind of give us an idea of what some of the potential pitfalls might be happening here. So if I want to solve that the absolute value of x is equal to 5, what can I say about the value of x? What is my answer here? If the absolute value of x is 5, what is x? 5. Could it be anything else? Good. Or negative 5. We have two solutions. What if I have the absolute value of x is equal to 0? What is x got to be? It's just got to be 0. Only one solution that time. If I have the absolute value of x is equal to negative 5, what's going to happen here? That's incorrect. What does the absolute value give us always? Not the opposite. Not quite. Great. So, can it ever give me a negative? No. So when solving an absolute value equation, we have three possible outcomes. We can have problems that have two solutions, we have problems that have one solution, and we have problems that have zero solutions. Everybody okay with that idea? So we have to be a little bit careful in solving these. So because we need to be a little bit careful, I'm going to outline the procedure that we're going to use each time. The first thing we're going to do is to isolate the absolute value on one side of the equation. The next thing we'll do is we're going to split that one absolute value equation into two linear equations. I'll explain more about how to do that in a minute. Right now we're just kind of outlining the procedure to give an idea of like what we're doing and where we're going. We'll talk about the details here in a minute. After that, we're going to solve those two linear equations. And then our last step is to check our answers. Everybody okay so far? Okay. Let's do some examples now to kind of get the finer points of this procedure and get you guys a little bit of opportunity to practice doing this sort of thing. So let's say we want to solve 2 times the absolute value of x minus 5 minus 4 equal to 2. So the first step says to isolate the absolute value. So to do that, we need to get rid of these 2 parts. Everybody agree with that? Which one of those 2 parts should we get rid of first? The times 2 or the minus 4? The minus 4. To get rid of the minus 4, what are we going to do? Add 4 to both sides. Very good. Okay. So now we're left with to get rid of this times 2. What are we going to have to do to get rid of the times 2? I've heard 3 answers, but all 3 of them were whispered so quietly I couldn't actually hear what they said. Would one of you ladies that venture to guess want to say it a little bit louder so we can hear it? I think that all 3 of them were kind of saying the same thing, so don't be shy. I think you all had basically the right answer. Multiply by... Okay, so multiplying by 2 is not going to cancel out a multiply by 2, but you could multiply by its reciprocal, which is 1/2, and that will cancel out the 2. Alternatively, what else could you think about doing? Dividing by 2 is the same thing. So either way of whether you want to multiply by the reciprocal or divide by 2, whichever feels more natural to you, is fine to do. I'm just going to write the divides by 2. Everybody okay with that? So step 1 is now done. We've isolated the absolute value. Everybody's okay with that? Now in step 2, what we're going to do is we're going to break this absolute value equation into 2 linear equations. So usually I do this to show myself splitting this up. The first linear equation, all I'm doing is writing the exact same equation with no equals, or with no absolute value sign. So instead of absolute value of x minus 5 equals 3, I'm just going to write x minus 5 equals 3. The second equation is almost the same thing. The left-hand side I'm going to write with just no absolute value sign. The right-hand side I'm going to make negative. Everybody's okay with that? Step 2 is now done. Step 3 tells me I just need to solve these 2 linear equations separately. So to solve the first linear equation, the x minus 5 equals 3, what should I do first? Add 5 to both sides. Very good. And then for the second linear equation, what do I need to do? Add 5 to both sides. Okay. So I have solutions to my 2 linear equations. The last thing I need to do is to check. So to do the check, what I'm going to do is I'm going to go back to the very beginning, to the original problem in its entirety. and I'm going to plug 8 in for x and see if that gives me 2. And then I'll also, at the same time, I'm going to plug 2 in for x and see if that gives me 2. Everybody okay here? So to simplify, the first thing I'd want to do is the stuff inside the absolute value. And notice when I'm checking, I'm just writing this question mark over the equal sign, because I don't know if this two sides are equal or not. That's literally what I'm checking. That's why I'm putting the question mark there. The absolute value of 3 is 3. And the absolute value of negative 3 is also 3. And then here I have 6 minus 4 is 2. Yup. And 6 minus 4 is 2. Yup. So that's me finished with 4. So I can say my two solutions are 8 and 2. Both of my answers that we found along the way are correct. Sierra?
Is there other than the formula like based on?
Yes. I would not have put the check step in there if that cannot happen.
Yeah.
So I promise you it can.
Well, I was thinking that things like, if it was going to be right every time and like somebody else we got wrong, so it's going to add up with 30% of the time where she's not coming.
Yeah. We'll do some more examples here in a moment. So let's see, we'll call this next one example B. All right. In step 1, what do we do? Okay, so overall the plan is to isolate the absolute value. To do that, the first step should be subtracting 2. Divide by negative 5, right? Everybody agree with that? Okay. Then what? Okay, then we'll split it into 2. So the first equation should be x plus 1 equals negative 2. And the second equation should be x plus 1 equals a negative of a negative 2. Or you could just write it as positive 2. I'll write it as negative of negative, so in the notes you can see that I'm still negating the other side. But if you just want to write that as 2, that's fine. There's no problem with doing that. Is everybody okay so far? So to solve this first equation, we'll subtract 1 from both sides, get negative 3, and subtract 1 from both sides to get positive 1. Everybody good with that? Okay. Let's do our check now. So I'm going to have negative 5, absolute value, negative 3 plus 1 plus 2 should equal 12. Then we have negative 5, 1 plus 1 plus 2 equals 12. Okay, so negative 3 plus 1 is negative 2. absolute value of negative 2 is positive 2. Negative 5 times 2 is negative 10. But plus 2 does not give me 12, right? So I'm going to cross out this solution for negative 3. That one doesn't work. This situation has a special name. This is called an extraneous solution. So we didn't make any mistake in our solving process. We just got an answer using that process that doesn't actually satisfy the equation. We call those extraneous solution. What root word do you see in extraneous? Extra. So this is like an extra solution that doesn't actually work. Everybody good? Let's do the other one. So negative 5 times the absolute value of 2 plus 2. Absolute value of 2 is 2. Negative 10 plus 2, that is not 12. So I have a second extraneous solution. So what would I write here for my final answer? So I'd say no solution. Did anybody notice a shortcut we could have taken during this problem? No, it happened way before that. Let's go back and look at this. I see an absolute value equal to a negative. Can that happen? No. Right here, I could say there's no solution. Now that required me noticing that I had an absolute value equal to a negative. In my experience, students often miss that situation, which is why I've kind of designed our procedure so that we'll still catch that situation if you follow the procedure. But if you're going along and you get an absolute value by itself equals something negative, you can stop right there and say no solution. Is everybody okay with that idea? Alyssa? Of course. Does that everybody see that shortcut there? And now that I point out, it's like, oh yeah, definitely. But the odds of you missing that are usually 50-50. Okay, so that's why the check is there at the end, to avoid those sort of situations. And when we look at some advanced topic in this equation, we'll get situations where one and maybe not the other works, or both of them don't work, and you're not in a situation where where you end up with something negative per se. So one more example, I think, ought to do it. What do you guys say? Sure. Okay, add 3 to both sides. Great. Okay. Then what? Okay. Dividing by a fraction is the same thing as, we said it earlier, multiply by the reciprocal. That's the way I'm going to prefer to write it. Again, it's okay to think about it as dividing by a fraction, but I always find that multiplying by a reciprocal is more intuitive in that situation. Thank you. Marshall, for you. Okay. Next up, we should split in 2. Very good. The first equation should be 2x minus 4 equals 0 is correct. And the second equation should be equals negative 0. But what is negative 0 the same as? Just 0. So immediately, what can I tell here? They're the same equation, so how many solutions am I going to get? I'm just going to get one solution because these two equations are identical. So I'm just going to forget about this other side because I don't need it and just solve one of them. So I get that x equals 2. And now I just need to check. And the check here is just a little bit shorter because I only have one value to check. Immediately I see that 2 times 2 is 4, and 4 minus 4 is 0. The absolute value of 0 is 0. 0 times negative 3, or 0 times 3/5 is still 0. And I get negative 3 is equal to negative 3. So my one answer is x equals 2. What do you guys think? Thanks.
I understand.
Good. We'll stop here.